Tell us a little bit about R2 Labs.
We build open autonomy control systems for industrial machinery and robotics.
Roby Lynn, CEO and co-founder of R2 Labs.
We're trying to kind of bridge that gap between software-defined robotics and the industrial automation. We're frustrated with the kind of current state of industrial control systems. They're proprietary, they're hard to use. Students are coming out of school right now. They already know how to write software, so why should they need to learn an entirely different skill set in order to program a machine? These are open architecture, easily programmable machine control systems that we use for agricultural robotics, process control, manufacturing, warehouse automation, etc. We're really on leading edge of a sea change in industrial automation.
Why do you think the industry's lagging so much?
These legacy players have been around forever. The next 5-10 years are going to be pretty huge change for the industry.
When did you quit your day job and say, I just need to build this thing?
That's kind of a funny story.
Hi everybody, welcome to Beyond the Bench, where we discuss taking hardware through production and the stories along the way. My name is Bill Brock, CEO of Peridio, the ecosystem for building and maintaining advanced embedded products.
Hey everybody, welcome to Beyond the Bench podcast, Hardware Stories That Matter. I have a very exciting guest for you all today. I met Roby a few weeks ago, or maybe a month or two ago at the Automate Expo, and it was Detroit this year, not Chicago. And we had many fantastic conversations. And Roby, CEO and co-founder of R2 Labs, welcome to the show.
Thanks, Bill. Yeah, excited to be here. It was great to meet you at Automate for sure.
Yeah, that was a really cool show. I think I said while I was there that last year we went and it was in Chicago, and it was palpably different being in Detroit, just with that being the epicenter of automotive and robotics, and just a really great energy, and it just seemed high volume, really exciting every day. So I'm glad we met.
I had never actually been to Detroit before that.
Oh, really?
I am from Chicago originally, so it was kind of a funny, collision of worlds, I suppose you could say.
I actually had my flight delayed, and I got to go to a Tigers game on the way out, and so I got my new favorite hat there. And everybody's like, "I live in Nashville." Are you from Detroit? And I'm like, "No, I've always been rooting for Detroit."
I'm a big fan of the Great Lakes region. I have a Great Lakes sticker on my water bottle here. Love the Great Lakes.
Yeah, it's amazing. Michigan is super cool. Well, cool. Well, before we get just too far sidetracked, which is inevitable on this episode in particular, tell us a little bit about R2 Labs. What do you guys do?
Yeah, so we build open autonomy control systems for industrial machinery and robotics. So basically, we're frustrated with the kind of current state of industrial control systems. They're proprietary, they're hard to use, they're not maybe beginner friendly, I'll say. And our team, we come from a software-defined robotics background, using ROS and that type of stuff. And we wanted to bring those ideas to industrial automation as a whole. As you know, the software-defined robotics people and the industrial automation people don't really even speak the same language. I'm not even sure that they get along. Each of them thinks the other is a moron. So, we're trying to kind of bridge that gap because we're all working in the same general area, right? We all want to automate machinery of some kind.
Yeah.
And, we view the future of that as being totally defined by software, not built around, legacy, proprietary, difficult to use things. Students are coming out of school right now. They already know how to write software, right? So why should they need to learn an entirely different skill set in order to program a machine? Now, obviously, I'm maybe glossing over some details here, but that's the general idea. So that's what we founded the company on, that idea. And we have taken that, developed a line of products that kind of reflect that. These are open architecture, easily programmable machine control systems that we use for agricultural robotics, process control, manufacturing, warehouse automation, etc.
And your hook is, and forgive me if I get this wrong, I'm not the CEO, so you'll get to correct the hook, but it's Python on ROS, right?
Yeah, so Python is something that can be used to write code that runs ROS. So we wanted to take ROS as the foundation for industrial control. So our controller is programmable in Python, obviously, but among other languages too. You can write C++ if you want. One thing I think that's particularly attractive to younger engineers and fresh engineers is the ability to write Python because it's easy to pick up. They're already used to it, so they don't have to know C++ necessarily to be able to do that. And, I think in general, the development speed of Python is faster. It's not it's not the best language for everything, but good general purpose language for a wide variety of tasks.
Yeah, yeah, very much front and center right now with the AI arms race as
Sure.
well. I mean,
Yeah.
everybody's learning Python. What was the moment in time when you guys bootstrapped, right?
Mm-hmm. Yeah.
Yeah. So when did you quit your day job and say, I just need to build this thing? What was that moment like?
Uh, that's kind of a funny story. I had worked in a number of corporate or startup roles over the years. So, well, let me back up. Let's see. I finished my PhD at Georgia Tech in 2019, and I had kind of explored going into academia actually. But so I went to interview for a faculty position at Northwestern, as a matter of fact, and which I did not get. They said their feedback to me.
Northwestern's Chicago, right?
Yeah, yeah.
So back to Chicago. Yeah.
Evanston,
Okay.
yeah. Their feedback to me was that I was too pragmatic. So I thought, okay, this
Let's you're an engineer.
this is probably not the path for me. It's funny because my dad's actually a professor, and so I thought, well, maybe that's what I should do, right? I mean, I
Hmm.
think I always had in mind when I was a graduate student that I wanted to have my own company, but I didn't really know what that would look like. So I tried the faculty interview, that didn't work. I ended up taking a job in industry, uh, which I stayed at for about a year, and then I went to another one, which I stayed at for about a year, and then I went to another one, which I stayed at for about a year, and then that was the end of it. But throughout that process, these were all in different industries. The first one was in continuous manufacturing. The second was in uh, biomedical device design, basically controls for a biomedical device, and the third was in CNC machining. And I yeah, it just wasn't really compatible with me, the whole having a job thing didn't really work out, but I had started this business on the side, let's see, 2021,
Hmm.
and so by the time I went full time, it was 2022, and then, the rest is history. So we
Very
had
cool.
started the company with the idea of building these types of control systems because we had worked with Siemens and normal kind of traditional industrial controls equipment, and after having come from software defined robotics world in graduate school, I was like, man, this has got to change, so and we basically bootstrapped the company through doing uh contract engineering work, I suppose, kind of targeted towards advancing our product idea, advancing our product development, design, manufacturing, et cetera. And, now we've gotten to the point where we're actually building them and selling them. And so
Cool.
that's super exciting. I mean, it's been a challenging road to do it, but it's been really good.
Where do you feel like you fit in the ecosystem? Do you align more with robotics? Do you align with industrial controls? What's the segment for you?
Yeah, I mean, I think that's kind of the challenge, right? Because these are two very different ecosystems trying to do similar things
Hmm.
at the high level. So I would say at the moment, we're probably more aligned in the industrial controls segment. I think part of that is driven by geography where we are. I think part of it's driven by, the number of opportunities for like existing manufacturing companies that need enhanced automation versus the number of companies that are building new robots from scratch. I think it's just there's a lot more customers out there right now that we can access for in the automation side. So
Yeah. Okay.
that's kind of where we're targeting at the moment, specifically manufacturing. I mean, we're based in the Southeast, right? So there's a lot of manufacturing here. There's a lot of companies with legacy equipment that needs new controls. There's a lot of companies that are like, oh man, we really need to get on this AI thing. We need to add vision. We need to, X, Y, Z. And so a deluge of those types of customers. So that's what we're going. I mean, we have a discrete product, right? This is a hardware software platform we can sell, we can integrate. The customer has existing machinery, we plug it up and, just it just goes versus I think there's in this area not as many robotics applications. But, it's kind of the difference between the two is blurry. You know what I
Yeah.
mean? So I'm
Yeah.
not I'm not saying, I mean, some of our biggest customers have been robotics companies. I'm not saying that we're shying away from that. I just think that the integrator ecosystem and all that kind of stuff around here is set up for the automation um, segment.
And what can you share about some of your early customers?
Yeah, I mean, they've spanned a range of industries. I mean, our product is a general purpose platform for controlling a machine. So we don't so much care about we care, but it's not super important what the end industry is, right? So that could be warehouse automation. There's a lot of warehouse automation going on here in Atlanta. So that's been a big one. That could be chemical processing. Our chemical processing customer wasn't based here, but so one exciting one we did for a company called Seabound. They build CO2 capture systems for commercial ships. And
Interesting. Wow.
as a sidebar, I happen to be a bit of a shipping geek, so this one was super exciting for me. I'm super interested in shipping, ocean liner history, yeah, just anything having to do with shipping. I'm really, really into it. I feel like I would have been an oceanographer had I not been an engineer. So, CO2 capture system. So it's basically a, device that gets installed on the ship. The exhaust from the engine goes through this chemical reaction. The CO2 is locked in,
Okay.
and then that is kind of offloaded at port and regenerated. The whole details of that. You can check their website. The company's called Seabound. But they came to us. They had a young workforce. They were looking for some easily deployable, easily programmable control system for this new process that they had. I mean, this was custom equipment they were building, and they wanted
Okay.
a partner to work with them to kind of supply the controls, help integrate, test, commission, make sure it all worked. So we built the whole thing for them based on our platform. We actually integrated it for them. They're based in London, so we went to London to
Ah, cool.
commission the system on
Did you
land.
take a boat to London?
I wish. Yeah, I wish. I think, yeah. I'm sorry, another sidebar. The Queen Mary 2, which is Cunard ocean liner. I've always wanted to take this ship across the Atlantic, but maybe one day. Anyway, no,
Yeah.
we flew Delta Airlines. We're regular Delta customers. Yeah. So we went to London to commission it on land, and then they installed it on a ship and went and trialed it out in the ocean, and it went great, swimmingly, as a matter of fact, no pun intended. Um, so that was really exciting. I mean, another cool one we did, similar type of ask, a customer doing agricultural robotics. They had a young workforce. They wanted a all-in-one control platform that could control a autonomous ground robot that was used to pick weeds. You can actually see this on
Okay. Interesting.
our website. Both of these projects are called out in case studies on our website. So this company, they were based in Arizona, and they were looking to kind of help alleviate the uh, human effort needed to remove weeds from a field of crops.
So they're like picking it out? Are they spraying or
So they were picking mechanically, but
wild?
we used our controller to run the entire robot. We had cameras on there that would detect what was a lettuce plant, what was a weed, and then deploy a digging device to remove the weeds. So that was super exciting too. But it was kind of an all-in-one thing, right? Similar to the Seabound, although totally different application. They wanted, oh, we want vision, we want telemetry, we want, easy programmability, we want a UI, XYZ, right? Same thing for the other one. So our platform, I mean, we have built this to be as kind of modular and extensible as possible. So you want remote access over VPN, you got it. You want web-based UI that ships standard. You want motion control. You want I/O. You want real-time, control of this and that, PID controllers, whatever. All that stuff. We don't. I mean, we don't think it makes sense to force customers to kind of a la carte all of these different components into their control system when all of what we view as a modern control system should be kind of can be built as an all-in-one solution.
What do you tell your mom you do?
I tell her that I do robotics and automation.
Okay. Yeah.
Yeah.
Yeah. It's pretty relatable.
Yeah.
Physical things, controlling, robot arms. Yeah.
Yeah, my dad, I mentioned my dad's a professor. He's a chemistry professor, and I've never been much of a scientist. It's, too abstract for me. So, he gets excited about things like, stars and, whatever. And I tell him like, Dad, it's way too far away. I really can't see it that well. It's either way too big or it's way too small, the stuff that you're interested in. So it doesn't really do it for me, but I'll tell you what does do it for me is heavy machinery. And I don't, so, it's just kind of funny. I mean, we're both interested in, you know, the physical world as a whole, right? But just from different viewpoints. I think he gets very excited about bacteria and this type of thing. Me, not so much.
Yeah, no, you and I are much closer aligned there.
Yeah.
So why do you think the industry's lagging so much? I mean, why do they need an R2 labs to come in and fix the world?
Well, I mean, I think there's legacy players that have made a great deal of money with business models that kind of rely on forcing customers to do things a certain way, use their proprietary platforms, technology, software, et cetera. And I think that, industrial automation obviously began a long time ago. And so these legacy players have been around forever. And they have built a lot of momentum, and I think that the end users, the actual customers that use automated equipment, use control systems, are just used to, like, this is the way that it is. You know what I mean? This is the status quo. I have to pay for a license in order to write code for my controller. From the software side, that is just completely outrageous. I mean, I can't even imagine. I mean, I'm obviously pretty young, so, there have been proprietary development environments for other things before, not just industrial controls. But now,
Sure.
you know, you use VS Code as an IDE, for example, and you don't have to pay for that. I mean, the thought of having to pay to write software is just completely foreign to somebody
Right.
in our kind of age group. You know what I mean? But I think that's the way it's always been for some of these legacy players, and they have so much market share right now that maybe there's not a huge incentive for them to change anything about it. Of course, I mean, I will say there's other aspects beyond just this. I'm not trying to say that, oh, it's just like evil corporations, whatever. I mean, look, there's a difference between writing software for a computer that, if it fails, isn't going to hurt anybody, versus writing software for a piece of heavy
Right.
machinery that, if it fails, is going to be catastrophic. So I respect that they're not the same thing necessarily. But, I do think that there is opportunity to do things differently. And I think that people our age and younger, really kind of expect that that is the way that it's going to work. It also, I mean, it stifles innovation in a way.
Totally. Yeah.
If you have to pay for this license to do this, and, oh, well, that's an extra option, and you have to talk to 10 sales guys in order to figure out the exact part number and blah, blah, blah. I mean, that is just so painful, so
Yeah.
painful.
Yeah, we bought a previous life before running Peridio. I was with Very Technology. We were booting up an electrical engineering team,
Hmm.
and I can't remember the product as Altium or
Mm,
something like that.
yeah.
The design so
Oh,
expensive, and
yeah.
I'm a software guy, and I'm just
Hmm.
like,
Hmm.
I've got
Hmm.
a $30,000 PO sitting in front of me for
Right,
like
right.
3 people to work. Like,
Yeah.
what in the world is going on?
Yeah,
Yeah.
yeah, Altium's expensive. Yeah. I mean, and in, the electrical design world, we see a shift towards open source tools for that, right?
Hmm.
There's
Yeah.
there's open source options for PCB design. And I think Altium's probably, or the Altium folks are probably, well, not that, Altium isn't a good product or whatever, but I think that they're probably seeing, like, oh, well, the momentum is moving towards community supported
Hmm.
free and open source software for PCB design. And we have worked with organizations, customers of ours, that they're not even going to bother to use Altium. It's so expensive. They can get the same thing done with the free tools. Why would they not?
Well, like a startup just can't even afford it.
Sure. Yeah.
Like you're bootstrapping a company. The first thing you're not gonna do is buy a $30,000 software package. You're gonna
Yeah. And
figure out what you need to do to use your brain and design something without that. Period.
And the same is
Yeah.
true for mechanical CAD, actually. So I mean, there's this project called Free CAD, which has its
Hmm.
limitations, but, it is getting better and better every day. And I would hazard a guess that the people at Dassault have probably had a lot of internal meetings about, like, what's going to happen to SolidWorks when Free CAD becomes so good that we're losing customers, you know?
Yeah. Yeah.
And I
My
think, oh yeah, go ahead.
yeah.
I,
My wife works at Autodesk, which
oh,
is
really? Oh,
really cool.
okay.
She's in corporate communications there. So
Okay. Okay.
yeah, hey, I yeah, through her own some Autodesk stock, but I think it's an interesting moment in time for Autodesk for sure.
Yeah, I mean, I'll give Autodesk credit for kind of approaching the mechanical CAD ecosystem a bit differently. One of the things that's difficult with, I am a mechanical engineer by training, so I am qualified to speak on this, by the way, even though,
I am not. I am
even though
definitely not. I am armchair expert at
that's okay.
best. Yeah.
No, I was gonna say I'm a mechanical engineer, even though I play a software developer on TV, because that is mostly what I do now, is just write software. But once upon a time, I did do mechanical engineering. I think that, I'll give Autodesk credit for, I think Fusion's a pretty good product, and the collaboration that could be done in SolidWorks is not the same. So, Fusion, you can kind of sync the stuff with this, cloud storage thing, and you can have multiple people working on the same project, whatever. That is a huge, huge step forward for mechanical CAD, that doing the same thing with SolidWorks PDM, for example, in my experience, has been much more, uh, not nearly as clean, I'll say that. And if you look at the kind of way that Fusion does it, it's really similar to if you were writing software and doing version control with Git. You can have
Yeah.
multiple
Got
people
him.
working on the same project. It's all stored in some, network server somewhere. People can commit at the same time. You don't have to share files around, manually. So things are moving towards, every industry is moving towards
Well, and they
the
had
software
a
direction.
really strong pivot, and I think that their success over the last 10 years was migrating really hard to a SaaS-based model
Mhm.
and those like collaboration features. And I think that I don't think, I know they were very successful due to that.
Mhm.
I think everybody's unsure of what AI is going to mean for this space as far as like AI and design tools. But
Totally.
yeah. What was that like moving from a mechanical engineer background to banging your head on software all the time? Like to,
Um, well, so I did my undergrad in mechanical engineering, and, at the time when I was choosing what to major in, I was like, well, I like cars. I'm a huge car guy. But I also like computers. This is me in high school, and I like messing with electronics, and I like, you know, writing code, and, that kind of thing. But like mechanical engineering, that kind of covers a pretty big ground, and I can still do mechatronics, and so I'll pick that. And so I did. I mean, it was kind of between that and double E, but I ended up settling on ME. And then when I went to graduate school, I thought, well, I've gotten to this point. I mean, I want to do mechatronics, I want to do automation, I want to do robotics. I think that, at the PhD level, it kind of matters more who your advisor is and what school you're at
yeah,
and what their resources are in terms of labs, rather than what's the actual degree title. So all of my PhD work was around, controls, software, et cetera. And
okay.
so, yes, I was in the mechanical engineering department, but, um, it was mostly just me writing control code.
What was your dissertation?
It was about controlling CNC machine tools from a CAM system without G code, which I can delve into this topic if you're interested.
We'll keep it light because I don't understand any of those words, and it'll just take the rest of the podcast. But that's really cool. Yeah. What's the TLDR?
It was okay. So I've kind of had this idea of, we need more open controls for a long time, and the
Okay.
PhD work was in the same vein. Georgia Tech, when I was a PhD student, had they still do, had a lot of CNC machines, and CNC machines are also notorious for being proprietary, difficult to use, hard to program, etc. They use this language called G code, which is how you write a part program, and G code is generated from something called a CAM system, which is computer aided manufacturing. This is how you go from a 3D model of a part to an actual manufacturing plan. So,
Yeah. Okay.
how does
Cool.
the machine move to cut this part out, right? There's a lot of steps along the way. You need an expert who knows machining to create the paths. Obviously, there's some AI elements coming into this, but you need something called a post processor, which basically creates the code for a specific machine. And there's a lot of things that can go wrong in the process. And additionally, once the code gets to the machine, the G code, there's limited data feedback back to the CAM system. So if something went wrong on the machine, let's say the machine crashed or whatever, the operator of the machine has to be the one to tell the CAM programmer, this part of the toolpath didn't work, versus the machine and the CAM system having some kind of more closed loop type arrangement. So that is what I was looking at. How do we create a closed loop CAM CNC system where the CAM system controls the machine feeds data back, and we can optimize or change or, modify the process plan accordingly.
And was there ever a moment, and this might be just me not understanding the underlying tech, but um, 3D printing, was that not an interesting area for you? Seems like that would be a very, very transferable skill set. Is that like already like largely solved and moved on to material science at this point, or what do you?
Yeah,
Yeah,
it's funny. I mean, well, I'll start with this. I'll say that there have there's always a hype cycle in technology, right? And when
yeah,
I was a student, 3D printing was super, super hot. I mean, it still is, but it was
yeah.
kind of like at its peak, of broad interest. And so there was a lot of research. There still is a lot of research going on with additive manufacturing at Georgia Tech. I was drawn to machining because the machines are bigger, heavier, louder, more dangerous.
You just like trucks. You're like,
Yeah, I just like
I just want the big dump truck.
greasy,
Yeah, yeah,
dirty,
yeah.
loud, powerful stuff. So I think the 3D printing was like, like it sits on a desk. It just didn't really do it for me. You know what I mean? I wanted that big, heavy machine. So,
Well, when we're all done with tech, my next adventure, I fantasize often about running a concrete business
mm,
and just getting to do that. I think that would be a lot of fun.
that's
Just
big
big,
machinery.
big dirty trucks, something with an American flag that
For
spins,
sure.
get to just get paid to drive that around. You don't, yeah, very different, problems.
I fantasize about ocean exploration.
Yeah, oh, that's cool. Wait, both. Yeah,
We
well,
could
a
we could do
concrete
both.
business and a boat.
We could do
Yeah,
both.
exactly.
Yeah.
Yeah, yeah,
So yeah, I mean, I think it was the draw of the heavy equipment. Um,
yeah,
and yeah, I mean, another thing I'll say, there's the hype cycle. We're in the AI hype cycle right now. There was a crypto hype cycle. There's hype cycles for everything.
yeah.
And the additive manufacturing hype cycle, I think I was, they said I was too pragmatic, right? So I think I was kind of a little bit, I don't know if put off is exactly the right way to put it, but just somewhat skeptical, I guess. Like there was
Yeah.
this, there was this kind of zeitgeist idea that, oh well, 3D printing is the only manufacturing process that's ever going to exist going forward. Everything else is legacy. It's all going away. 3D printing has solved everything. But like that wasn't true then, and it's not true now. And frankly, I don't think that ever will be true. There are some things for which 3D printing just doesn't make sense, and that's fine.
Right.
There's tons of ways to make stuff, and each of them has its own advantages and disadvantages. And so machining has been around for a long time, and it just draws me in.
Tell me about Atlanta. How you liking Atlanta? You moved there for Georgia Tech and you're staying. So what's it like?
Yeah, Atlanta's a wonderful city. I actually moved here with my family before Georgia Tech, so I ended up I went to high school here,
When was
and
that?
what was that like?
Wait, when did you graduate high school? Like
2009,
2014? 2009?
2009.
Okay, cool.
Yeah. So that was a while back. But yeah, Atlanta's a great place. I mean, it's a great place to build a technology company. I think I'll say we have an amazing airport where we can go anywhere, which is fantastic. We have um the affordability is pretty good. Maybe won't be forever, but right now is pretty good comparatively. The tech ecosystem here is really strong. I mean, Georgia Tech is obviously great, so talent pipeline, but just in terms of um, number of businesses being formed here, number of businesses running here, there's a decent number of robotics companies here. And actually, I'll shout out to our local robotics interest group, Robo Georgia, which is kind of the mass robotics equivalent for our area in Georgia here, has been growing. And that's super exciting because a lot of new people are coming in that work in the industry or that want to work in the industry, and active community. So I'm not sure that I would really want to be anywhere else. It's a great place. My only gripe about Atlanta is it is way too hot during the summer, and the summer lasts way too long.
Hmm.
But
Yeah.
beyond that,
I
it's pretty good.
I'm in Nashville, originally from Chattanooga, and it was always a decision: do we drive to Atlanta or Nashville for the flights?
Hmm.
And Atlanta was always cheaper, but it's such a crapshoot getting through the city and getting to
Oh,
get
oh,
the
I
really
know.
be very, very strategic about Atlanta travel, but
Yeah,
it's
yeah,
booming now down there. It is
yeah.
blowing up.
I mean, the travel thing is an issue. I guess that is another gripe that I have. I know people, from LA are going to say, "Oh, you haven't seen traffic until you've been here." Fine, maybe, whatever. But like, I know my
Mm-mm. They
experience.
people from Atlanta don't go. I mean, people from LA don't go to Atlanta. They're like they just live in LA. But like Atlanta's also horrible with
Yeah.
traffic. I think it's as bad as LA. I really do. So
So,
whatever.
we'll have meetings in the city during the day, and it can take me 45 minutes or 2 hours to get there and back. It's so yeah, that can be a bit challenging. I thought during COVID, I was like, man, Atlanta traffic problem solved. It's never coming back. But boy, I was very
It
wrong.
came back.
Yeah,
Yeah, yeah.
came back hard.
Well, we're getting to about a half hour. What do you like want to leave us with about R2? Like what's top of mind for you? What's next?
Yeah, I mean, we're excited. I think we're on a great path right now. We're excited to continue growing our customer base, working with larger and larger enterprises, larger and larger deployments for them. I think we are excited to explore some stuff with Peridio actually in terms of, how do we manage software? How do we manage a remote fleet of controllers? We feel that we're really on kind of the leading edge of a sea change in I
Yeah.
keep using the kind of ocean related terms here, a sea change in um, industrial automation and robotics. More software defined stuff, transition away from kind of legacy ways of doing things, and we're really excited about that. So I think that the next, I don't know, 5-10 years are going to be pretty huge change for the industry, and we're glad to be right at the forefront of that.
Yeah, I think you guys are really well positioned. We're excited to partner. And it's very clear. I love what's happening in tech right now and the South too.
Hmm.
And the focus on physical systems
Hmm.
is really great because for so long, investors shied away from, and you guys are bootstraps. You don't worry about investors, but they do fund things that get you guys money.
Yeah.
People just shied away from hardware in general, and robotics and industrial controls felt like they were stuck in the past, but
Hmm.
people were too afraid to really take a crack at solving the problem. And it feels like with AI, this huge hype cycle that we're on right now, this big wave, like, oh wait, now we can do things faster in the real world. We can do things better in the real world. And what your demo at Automate, I found really compelling, and I think also your some of the earlier trends in this conversation around people need you because the next generation of technologists don't understand or want, like, who wants to learn how to program a CNC machine?
Yeah.
That sounds
Yeah.
shitty. That
Yeah.
sounds like a terrible job, and there's going to be some like it's just not fun. And so you guys are really up to some good work there, and
Yeah, I
psyched to see where
appreciate
you
that.
go.
I mean, another thing I'll say, there's a lot of interest in our area for like B2B SaaS type things. And that's totally different industry, obviously. HR software, whatever, payroll, that's just another universe. Um, but industrial controls, robotics, etc., that takes a specific type of team to be able to do that kind of stuff and a range of expertise that one kind of software person is not necessarily going to have. You have to know electrical, you have to know mechanical stuff, you have to know software, you have to know controls, you have to know dynamics, a lot of things. And
And you got to know safety. Software people don't
safety,
know
totally.
safety.
Yeah.
Software people are
Right.
so reckless.
Right.
No,
Right.
present company included. Yeah.
Yeah, and so I mean it is something I think that is not necessarily easy to explain to people that have not worked in this, and that goes for investors as well. We have talked to a lot of investors about our I think there's a time in the future where we may go that route, but we've talked to a lot of investors about what we do, and some of them are looking at me like I'm speaking another language, but there are some that are like, we get it, you know. This makes sense. Like this is something we're interested in. So I guess what I'm saying is that um it's different. There's kind of human lives on the line in a way here. It's not the same as like a typical software based startup industry.
Totally. Well, not we, me, this company, we have really good connections up in Boston. And I think that's like if you're going to do some fundraising journey, Atlanta, clearly you got connections there. But I think that the Boston has a strong
Hmm.
network of hardware investment and just general like cutting edge robotics shops that I would, if you haven't made many trips up that way, I would get on the LinkedIn Navigator and start exploring that. You'll have
Yeah.
you get some people excited for sure.
Yeah, definitely. The software for hardware idea.
Yeah. All right. So we're two white guys in tech, but more importantly, we're two Southern guys in tech. You're a transplant. Who is your favorite Atlanta-based hip hop artist that came out last 20, 30 years? That's a contentious topic at the R2 Labs.
Easy answer, 2 Chainz.
2 Chainz.
Yeah.
All right.
I don't even know how to think about that one. He and I think we really share a lot of the same interest, and I'll leave it at that.
Yeah. Well, I think that's a fantastic note to close on. Roby, thanks so much for coming on. It was awesome catching up, and we'll see you again really soon.
Yeah, man. Sounds good. Thanks a lot.
All right.
Okay.
All right, everybody, just a quick reminder, this podcast is presented by Peridio, the ecosystem for building and maintaining advanced embedded products.